right, here's our second video for section 3.2. We just got done checking ordered pairs and determining if they're solutions into our equations that have two variables. We plugged in our x coordinate, we plugged in our y coordinate, and we determined if that was a solution, if the equation was true, right? Well, a linear equation in two variables is an equation that can be written in the form ax plus by equals c. As long as a is not 0 and b is not 0, then this equation is a linear equation. What it's always going to end up looking like when you graph it is a straight line. Now, some of you might have heard of this before, y equals mx plus b. It still has a y and an x, it's just written in a different form. So two different ways of writing a linear equation, a straight line. Now, for right now, we can graph a linear equation by finding and plotting some ordered pairs, some points, right, that are solutions. Well, how many points do you think we need in order to be able to determine what a line is, or where the line is at? Maybe some of you had a few answers, but you would need at least 2 points. If I can figure out two ordered pairs that are solutions to my equations, I can plot those 2 points and I can connect them always with a straight line. Now, I'd like you to do a little bit more than 2. I'd like you to do at least 3, so that way we can make sure that we definitely see the pattern. If we can find 2 or 3, really, points, then we know kind of where the line is going to be, and it's going to follow that same pattern. Okay, so I want you to look at example number 3 with me. Graph each of the following equations. So it says here, graph 3x plus y equals 12. What we can do is we can find ordered pairs that will work. Now remember, we can always find an ordered pair if we know one of the coordinates. If we know the x coordinate, we can find the y coordinate. If we know the y coordinate, we can find the x coordinate. So what's nice is we get to pick any x or any y and find its partner in its ordered pair, right? So pick any x that you'd like. In this case, I started with 0 because that's always the easiest for me. We can always find its partner, its y value, by plugging in 0 for x and solving for y, like we did in the last video. So if I take my equation and I plug in 0 for x, I can solve for y, and I ended up getting y equals 12, right? So that means there's an ordered pair, a solution to the equation 0, 12. Let's do that a few more times with a few more coordinates. Pick another coordinate. You can pick a y or an x. I'm going to go ahead and pick another x. Let's pick 1. If I plug in 1 for x, I should be able to solve it for y. I ended up getting y equals 9. Maybe pick a y this time and see if you can solve for x. If you pick y equals 6, what do you end up getting for x? I got x equals 2. So now I have at least 3 points that I know are solutions to this equation, meaning they are points, coordinates, on this linear equation, on the line. So what I can do now is I can plot those 3 points. We've plotted those points in the past, right? The first one is 0, 12. That means left or right, nothing, and up 12. You can see my green dot. The next ordered pair is 1, 9. That's right 1, up 9. My third ordered pair is 2, 6. You can see then that I have a nice straight line that's going to look something like this, and it's going to look like a line, a linear equation. Now that's one way of doing it. Or if you notice that this equation was written in what we call standard form, ax plus by equals c. Maybe you notice that I can actually put this equation into a y equals mx plus b, another form that we're going to talk about later. If you notice, when I subtract 3x to both sides, I end up getting the equation y equals negative 3x plus 12. I'd like you to hold on to that equation for a second, because I'd like you, after we're done graphing some of these, to see if you can find any sort of pattern between this equation and the graph. Let's do b. I'm going to move this out of the way for, oh no. I'm going to move this out of the way for a second. We'll bring that back in a second. But if I give you this linear equation, it's in the form ax plus by equals c. I have an x and a y, so I know it's going to be a line. Let's go ahead and figure out where this line is at by plotting some of its ordered pairs, some of its solutions. So pick some x's or y's and then solve for the missing variable. I always start with 0. That's always the easiest. So if I take my equation, I plug in 0 for x, let's figure out what y is. I ended up getting 5y equals 20. If I divide both sides by 5, I ended up getting y equals 4. So I know that there's a point on this line at 0, 4. Pick another one. I picked x equals 5. If you plug in a 5 for x, what do you get for y? I ended up getting 8. Did you? All right. I'm going to plug in 0 for y. If I plug in 0 for y, what do you get for x? Ooh, I got -5. Did you? So it looks like we have 3 ordered pairs that are on this line. Now that we have at least 3 dots, I can plot these ordered pairs and figure out where my line is at. I have the point 0, 4. That's left to right nothing, but up 4. I have 5, 8. That's right 8 up, right 5 up 8. And I have the point -5, 0. That's left 5, but up nothing, or down nothing. So then I can connect these 3 dots with a straight line, and so I have my line that looks like that. I use standard form, but maybe some of you put it in y equals mx plus b. I did that by subtracting adding 4x to both sides, and then dividing everything by 5. I ended up getting the equation y equals 4/5 x plus 4. Hold on to that for a second, and let's see if you can come up with any sort of pattern for that equation. All right, we've got 2 more that look a little bit different. On these ones, they look like they're not quite in standard form. Now you can put them in standard form if you'd like to, make it look like ax plus by equals c, or you can leave them in the form that they're at. Still noticing that they're still linear equations because we have an x and a y. They're just kind of rearranged a little bit. These ones actually look like y equals mx plus b. Now, I can graph any of these lines by, remember, picking one coordinate and finding the other coordinate, finding ordered pairs that are solutions to the equation. So on the first one, I'm going to pick a couple different x's, substitute them in to find out what y is. I'm going to plug in 0 for x. I'm going to plug in 1 for x. I'm going to plug in -1 for x, just trying a few different numbers. When I plug in 0 for x, -3 times 0 is 0, so I know that y is 0. I'm going to plug in 1 for x. -3 times 1 is -3. And I'm going to plug in -1 for x. -3 times -1 is +3. So now I have 3 ordered pairs that are solutions to the equation that are on the line, and I can plot them to graph the line. I have the point 0, 0, which is at the origin. I have the point 1, -3, that's right 1, down 3. And I have the point -1, 3, that's left 1, up 3. I can now connect these 3 dots with a straight line. Straight as line as I can. And now I know exactly what this graph looks like. It's a linear equation. I should probably be putting arrows on all of these lines since lines go on forever and ever and ever. That's probably a better way of writing those, but we have a line here for example number 4a. What about example number 4b? Let's pick some x values here. I picked 0. Now be careful. You might want to pick a certain x value if you don't want to have to deal with fractions. So what x value do you think you can plug in so that if we multiply it by 1/2, you won't have any more fractions? How about anything divisible by 2? I picked 2 and -2. Maybe you chose x equals 4 or 6. Any of those would get you nice, cute little whole numbers. Now you can still do fractions, but your graph might not be as exact because then you're going to be estimating some of your ordered pairs, some of your plots your dots when you plot them. If I plug in 0 for x, I ended up getting 0. When I plugged in 2 for x, 1/2 times 2, I ended up getting 2/2, which is 1. When I plugged in -2 for x, I got -2 divided by 2, which is -1. So now I have 3 ordered pairs. I can plot these 3 ordered pairs to figure out where my graph is at. 0, 0, 2, 1, and -2, -1. It looks something like this. All right, now that we've actually plotted and graphed 4 different lines, what I'd like you to do now is take a minute and I would like you to look and compare all 4 of these. I would like you to compare their graphs with their y equals mx plus b equations and see if you can find a pattern with its equation and the numbers in the equation versus the graph of the line. Take a few minutes and see if you can come up with anything that you've noticed, any sort of pattern we can use to make it maybe easier for us to graph instead of having to always find a whole bunch of different ordered pairs. All right, did you come up with anything? Okay, this is kind of a spoiler alert because we will be talking about this a little bit more in detail in a future section. But you may have noticed that the y-intercept happens to be the same number here as the last number in my equation. I touched the y-axis at +12. I touched the y-axis at +4. I touched the y-axis at 0, right? That's why there was no number in the back there. Same idea with this one. There was no number in the back of my equation, and so there's really a +0 in the back, and so it crossed the y-axis at 0. That's actually my y-intercept always. So what about the other numbers in my equation? Did you notice anything about those? Like the -3 and the 4/5 and the 1/2? Maybe you noticed that my line on the first one sloped down. It was a negative slope. Well, that's because this 3 is negative. And maybe you notice that it sloped at a 3/1 ratio. Well, that's the slope. Or if you look at the next one, B has a slope of +4 over +5, or 4/5, and it went up. My line was up. Same idea with these other ones. You can double check those. We've got a -3/1 rate slope, and we have a +1/2 slope. So the number next to the x happens to be my slope. I have a slope and a y-intercept. So now, if I can get my equation to look like y equals mx plus b, the m and the b mean something. The b means the y-intercept, and then m means the slope. And maybe I can use those numbers to graph it more quickly than having to pick 3 separate points and finding those values. Kind of cool. We'll talk about that a little bit more in the next section. For now, you can always plot lines, graph lines, by finding ordered pairs, picking an x-coordinate and finding its y-coordinate that matches, or picking a y-coordinate and finding its x-coordinate partner, plotting those points and connecting the dots.